we're starting.
Okay, so the second section is probably going to cover a lot of new information. I think the first section is a lot more review for you guys than this one. Okay. Let's do all this. Hold on. That's it. Okay. So for microscopy, he usually tests, like, you have to know everything on this slide. Like, he can ask a question about bright field, what is bright field, dark field, phase contrast, etc. He also wants to know the difference between electron microscopy and light microscopy. So electron microscopy, I'm just not going to say that word. It uses electrons. The magnification power is higher. The resolving power is higher. The electrons are transferred in a vacuum. With light microscopy, again, light X, the light goes through air instead. So bright field, it's the background is bright. That's why it's called bright field. And the actual sample is what you're looking at, and that's going to be dark. For dark field, the background is dark, and your actual sample is bright. Fluorescence uses UV light, and then you're seeing if your samples give off longer wavelengths, and then they show fluorescence. Phase contrast looks at the density of the cells, and you're looking at the relationships of structures in the cell in relation to each other. For electron, the transmission electron microscope, X, you can cut the cell into thin pieces, and you can look at very detailed structures with that. The transmission, TEM. For the scanning, you can look at the surface of the cell. Then the refractive index, that is when, so for microscopes, when you have two surfaces that are different, the refractive index are usually different. So the light will bend as it enters the second surface. So we use oil because the oil will limit the contact between, if you have the glass slide and you have your microscope lens and you put the oil, then the air in between that portion will be lessened, so your light will bend less, and you'll have a greater clarity with your picture that you can see, greater resolving power. Because the oil is very similar to the refractive index of the glass. Magnification, he wants you to know what magnification is. It's just how large things can get magnified. So the greater the magnification power is, the larger the picture is. Resolving power is resolution, is how clear aspects are when you're viewing something. Usually if you don't put oil, there's a very limited degree to which you can see. It's the resolving, because then the light is bending too much, and your picture's not very clear, even if it is big, if the magnification power is big. And then shorter wavelength, that's because if the wavelength decreases, then your energy increases and your resolution power is greater. But you don't need to know that. That was just for your curious. Okay. Wet mounts, he stressed that they're useful for looking at utility, and he'll definitely ask questions about the stains, positive, negative, grad and everything, but we'll go through it. Okay, so,
Sorry, what did you say the wet mount was useful for?
motility. So in lab, if you look at a wet mount and like a pond sample, you can see all the different microorganisms moving around and everything. So it's good for that because they're actually like alive. You're not looking at a dead cell. So for the simple staining, the cell membrane, he said, someone had a question about this in the chat room. He hasn't specified which part of the cell, if it's the cell membrane or the cell wall, both of them can be negatively charged. I think the question was just poorly worded by a TA, so he probably won't put that in the exam, because I watched his lectures again, and he just said cell surface. So the cell surface is negatively charged, and that's why when you have a positive dye, it tracks to the cell surface, and you can see color, because the specimen is colored then. And the background will be contrasted against that. If you use a negative dye, then you're looking at the background because since the surface is negatively charged, the negative dye will repel that negative surface, so then it won't attract to your sample, and the background will be what you're looking at. And you can see a picture there. This is positive because your sample is highlighted. And this one, you can see that the background is the one that's highlighted over here. It repels the negative surface. Okay, so gram staining. Okay, you should know the process, how a sample is fixed. So you put the sample on a glass slide, then you air dry it, you heat fix it, and then you put your crystal violet, your primary stain, and then you put the iodine, which just amplifies the color and it sticks more strongly. Your decolorizer will remove that, and then if you have a gram negative, when you put your counter stain, it'll turn red. Gram positive will stay purple, and we'll go over why too. So acid fast strain, people probably not ask into like a detailed question about it, but just in case, you can't use gram staining on them because they have a different lipid composition for their cell wall. So when you add the decolorizer, it doesn't wash off. So your cells will always be falsely gram positive. They'll always be purple because the decolorizing step doesn't work. And that's for mycobacterium. And structural stains, he did cover this. This is for medically important structures like flagella, an endosome, a capsule, and that's what it stains. So pictures of simple, it's called differential stains because it differs between two types of like bacterial populations. So there are different types of bacteria that go in gram negative and different types of bacteria that go in gram positive. And simple because you're just looking at the morphology of the cell, the shape, the size, the pattern, the arrangement. Okay, for this, you guys probably want to write this down, if I can. Okay, so he has asked questions about which type of diseases are associated with different cell shapes. So for gram negative coccus, you will have, it's associated with Neisseria, which causes gonorrhea, and also pneumococcal meningitis. And then for gram positive, the coccus again, you can have streptococcus or staphylococcus, and streptococcus are the ones in chains, and staphylococcus are in like clusters. And then Vibrio is associated with cholera. The gram-negative Bacillus is associated with E. coli and Salmonella. And then the gram-positive Bacillus is associated with anthrax and
tetanus and gangrene.
Okay, yeah, and tetanus.
What was that last thing you just said?
The tetanus? Anthrax, yeah. That's for the gram-positive Bacillus.
What was the negative of the Bacillus?
The negative is E. coli and Salmonella. Yeah. Yes. So the gram-positive are going to be Streptococcus and Staphylococcus. Streptococcus in chain, Staphylococcus and cluster. He has had a question on that as well. For the gram-negative, you're going to have gonorrhea. Gonorrhea and pneumococcal meningitis. And then there wasn't anything else.
Oh wait, do you want to talk about the spiral and corkscrew?
Yeah, he didn't add any diseases for those.
Oh, he didn't?
It was just the major ones. Yep. Okay. Wait.
What was the gram positive for Bacillus again? Anthrax, tetanus.
Anthrax, tetanus, and gangrene.
Which one?
For Bacillus?
For Bacillus, it's going to be anthrax and tetanus.
And negative?
We know Clostridium is tetanus.
Oh, never mind. It was different what she said.
Anthrax.
Just put anthrax because that's what I had.
Okay, and gangrene.
Huh?
And gangrene.
That's like also Clostridium. So
Okay.
yeah, just the Bacillus is anthrax.
You had anthrax. Like that's what I want. I mean, in
Just put
lectures it
anthrax.
said anthrax.
Just
So yeah.
You had something for syphilis and Lyme disease?
Syphilis?
Yeah, syphilis and Lyme disease were the spiral and corkscrew shaped ones. Spirochetes.
But these are the major ones. Like, he hasn't tested on other ones, so this is one case stress. I mean, you should know those, but yeah, those are the major categories if you want people to know. Any other questions? No?
Very safe and sorry.
Yeah,
So for fluorescent microscopy, he wanted you guys to know that you can use it to determine where antibodies are reacting with bacterial cell surfaces. So you can attach like a fluorescent dye or like a protein that will express fluorescence, and you can see where it's interacting with the microscope. And that's the picture right there. And the tip is the portion that's actually the variable portion for the antibodies. Okay. For this one, there are different lasers that go from different directions for that hit a sample, and they make like a 3D picture. So that's all. Okay. This is just a summarization of everything I talked about for this one. He didn't go over these two. You don't have to pay attention to that. Okay, this again I talked about. You definitely want to know the difference between electron and light microscopy. They use electrons again, higher resolving power, higher magnification for electrons. Electron microscope. Okay, I think Anjum went over this, so I'm not going to really spend time going over this. Cilia are only present in eukaryotes, like the mucociliary, like the mucus in your throat, and it goes down. Like I think it's called the mucociliary elevator or something like that. Does anyone have any questions on this? I think it's like pretty self-explanatory what everything does.
Does he ever have pictures on his exams?
No.
No.
Cool.
Also, remember, like from the previous slide, which I didn't go over, is a point about endospores, which are only found in prokaryotes, and it's unique to bacteria for like survival.
Yeah.
So like they can turn into endospores in really harsh conditions and turn back when it's not as bad anymore.
Cool.
They can like go from endospore back to like their normal like bacterial state of being when like the conditions are no longer as harsh.
They can do that as many times it requires.
Not
Yeah.
every
Well, no.
bacterial. It's only the Bacillus and the Clostridium. So
Clostridium.
you might test me on that actually, because those are the two bacterial populations.
Wait,
Bacillus
Clostridium.
and Clostridium.
Bacillus and Clostridium.
Yeah. And I think he said that 3 times, so it's telling me something.
Can you repeat that? Bacillus and
Clostridium,
what is it?
they can form endospores. Okay, everyone's good till this point? Okay.